Hello everyone. This is our second video of the chapter 2, structure of atom. In the previous video we have discussed a lot about the discoveries of cathode ray and anode ray. Today we will discuss about the properties of anode rays. First, in the as you know that E. Goldstein discovered the anode ray and proton. So the properties of proton is number one, it or anode rays. They move in straight line. They are positively charged ray. They also deviate in electric and magnetic field. So they are electromagnetic ray as they deviate in electric as well as electric and magnetic field. This ray is heavier than cathode ray, as it can't move, but it can't penetrate the cathode ray. The penetration power of cathode ray is more than the anode ray. So because this gas is heavier than the cathode ray, the E/M ratio, as I have discussed in the previous video, that E/M ratio of cathode ray doesn't depend on the gas present in the discharge tube, but the E/M ratio of the anode ray, the E/M ratio of anode ray depends on the gas present in the discharge tube. As electrons are same for each and every element, but protons are different for each and every element. These are the properties of anode ray. After the discovery of properties of cathode and anode ray, we can conclude that some properties of the fundamental particles, electron and proton. Electron and proton. The mass of the electron, mass, charge. The magnitude of mass of the electron is 9.1 into 10 to the power of minus 31 kg, or 9.1 into 10 to the power of minus 28 gram. And mass of the proton is 1.67 into 10 to the power of minus 27 kg and 1.67 into 10 to the power of minus 24 gram. And the charge on the electron is its magnitude is minus 1.6 into 10 to the power of minus 19 coulomb, and here it is plus 1.6 into 10 to the power of minus 19 coulomb. The charges of both are same, but they are opposite. In charge, but the magnitude are same. After this, let's discuss the discovery of radioactivity by Henry Becquerel and Madame Curie. Radioactivity. What is radioactivity? Spontaneous emission of radiation. We can say that spontaneous emission of radiation from a substance or an element, is called radioactivity, and the substance is known as radioactive substance, like uranium, polonium, radium, etc. are radioactive elements. Radioactivity. The spontaneous emission of radiation is radioactivity. From the radioactive element is kept in the lead box. Because this is the most stable radioactive lead box. This is lead box. Now, if there are three types of emission from the radioactive substance: alpha, beta and gamma. There are alpha ray, beta ray and gamma ray. There are three types of rays formed from the radioactive substance. Not necessarily each and every radioactive element have these three rays, emission of these three rays. Some element can radiate only alpha, some radiate only beta, some radiate only alpha beta or gamma, or some radiates alpha gamma or beta. What are the properties of these alpha beta and gamma rays? So let's summarize the properties of alpha beta and gamma rays. Alpha, beta and gamma. These are the alpha beta and gamma rays. The mass of the alpha, mass of the alpha is 6.67 into 10 to the power of minus 27. 6.67 into 10 to the power of minus 27 kilogram. That means kilogram. We can say that it is 4 AMU, because this mass, the identity of this ray, alpha ray, the identity of this ray is doubly positively charged helium ion. Doubly positively charged helium ion. The mass of the helium is 4 mu. So the mass is 4. Beta ray. The mass of the beta is 1.67 into 10 to the power of minus 27 kg or minus 24 gram. That means it is about 1 AMU. And its identity is like electron. Its identity is like electron. And the mass of the gamma is negligible. Mass of the gamma is negligible. And this ray is a negligible ray. This ray is the negligible ray. And the energy of this ray is very high. So it is high energy radiation. High energy ray. Identity rays. The magnitude of charge. plus 2 minus 1 and this is 0. Velocity. Velocity at alpha ray is heavier, so its velocity is 1 by 10 of speed of light. And it is about same as speed of light. And it is more than the speed of light. Just more than the speed of light. Speed of light. Or we can say that it is 3 into 10 to the power of 8 meter per second. This is negatively charged ray. This is positively charged ray. This is negatively charged ray. This is positively charged ray. This is negatively charged ray. And this is neutral. Now, let's start the model of atom. As you know from the previous classes that J.J. Thomson proposed a model first. The first model of atom is proposed by J.J. Thomson. That is Thomson's model of atom. Model of atom. First is Thomson's model of atom. J.J. Thomson proposed that an atom is a sphere. The substance which has the minimum surface area is a sphere. So he considered that atom is the smallest particle of matter, so atom must be spherical. So he considered that an atom is a positively charged sphere in which electrons are embedded like plum in the pudding, and the magnitude of negative charge is equal to the magnitude of positive charge. You all know this model of atom, and I am not going to describe any more this model of atom, as this is just proposed by the J.J. Thomson. There is no experimental proof of this model. To prove this model, Rutherford did a renowned experiment, that is alpha ray scattering experiment. In the alpha ray scattering experiment, a source of alpha ray is used by Rutherford. This is the experimental setup of Rutherford alpha ray scattering experiment. Rutherford wanted to know the position of electron and magnitude of proton, also the position of electron in the J.J. Thomson's plum pudding model. To know that, he used an alpha ray source. So this is alpha ray scattering experiment. Alpha ray source. This experiment he did with his students Giger and Matson also. They are also involved in this experiment. So in this there is a source of alpha ray. This is the source of alpha ray. Alpha ray source. Some type of radioactive element is placed here, and this is cadmium sheet. This is cadmium sheet which absorbs the other rays if emitted from this source. So here is a slit between, at the center of the, in it, a slit in it, and this ray when emit, it passes through the slit and fall on the, this is gold foil. Gold foil. And scatters. Scatters due to presence of these atoms in it. It scatters. It scatters and makes some pictures on this zinc sulfide coating. By the observation of these pictures, Rutherford concluded some ideas. Like, first is, as you know, as a class 11th student, you all know that what are the observations and conclusions of Rutherford? Observations and conclusions of the Rutherford alpha ray scattering experiment. First is, most of the ray passed straight through the gold foil. So first is, most of the ray passed straight through the gold foil. Straight through the gold foil. Second observation is, some of them deviated or deflected by small angles. And the third one is, very few rebound. Means some of them deviated by small angles. Deviation from a small angles means there must be some positive charge present at the center of the atom, and very few rebound. These are deviation. This deviation is due to presence of electron in its circular paths, and this deviation is due to, these deviation are due to presence of this positively charged. As we know that alpha ray is positively charged ray, so when positively charged ray come from the positive nucleus, then it deflected by small angles. On the basis of these observations, he concluded that Rutherford conclusions of Rutherford's are, he concluded that most of the space inside the atom is empty. Most of the empty space inside an atom. Second, according to the second observation, these deviations are due to presence of positive charge at the center of the atom. And at last, very few rebound. That means the positive charge and mass resides at the center of the atom, present at the center of the atom. These are the conclusions of Rutherford's alpha ray scattering experiment. On the basis of these conclusions, he gave his famous nuclear model of atom. His famous nuclear model of atom. And according to the nuclear model of atom, according to the conclusion of his alpha ray scattering experiment, Rutherford gave this nuclear model of atom. According to the Rutherford nuclear model of atom, most of the mass and positive charge resides at the center of the atom in very small space. Center of the atom in very small space. The size of the nucleus is very small as compared to the size of the atom. If the size of the atom is 10 to the power of minus 10, the size of the nucleus is 10 to the power of minus 15 meter. Second one is nucleus is surrounded by negatively charged particles. This nucleus is surrounded by negatively charged particles, which we know that are electrons, which moves in circular paths called orbits. This moves in orbits. These are orbits. This moves in orbits. Electrons and the nucleus are held together. These electrons which moves in the orbits are held together by an electrostatic force of attraction. Here there are some drawbacks of this model. We will discuss the drawbacks of Rutherford model, atomic mass, mass number, etc. in the next video. Thank you.